All right. So in our first 2 days, we did all this stuff on coordinate graphs and things. We're done with that now. How is that connected to this? Well, last class we did dilations, all right?
Yep.
Do dilations keep things the same size?
No.
No. Is it a rigid motion?
No.
No. So if it doesn't keep things the same size, they're not congruent. And so I told you what they were.
Similar.
They are similar shapes. And so we are now moving forward with that. The rest of the unit is pretty much about similar stuff. Okay? So what you've got to be good at is fractions. Okay, mainly simplifying fractions or typing fractions into a calculator to get a decimal that you can tell if it's the same as another one. Okay? And so similar polygons are the same side, nope, same shape, but they are a different size. Okay? So they are non-rigid motion results. Okay? Now I told you last time what makes polygons similar. So for candy, if someone could tell me one of the two things that makes polygons similar. Okay? Oh, give it a shot.
Congruent angles.
It does have all congruent corresponding angles. Okay? It has to be the ones that correspond. All right? And you can get candy for that. And the other one? No. It's just a definition. It is a definition. It's not an implied statement. Okay? And what's the other thing that has to be true for similar stuff? Yes?
The ratios.
The ratios between the sides have to be, they have to be congruent or equal. Scale factors are numbers, they have to be equal. Well, if you have equal fractions, that's called being a proportion. And so the corresponding sides are proportional. Okay? And all that means is equal ratios, equal fractions. So we're going to be building lots of fractions that need to equal each other. Okay? And that's where the simplifying fractions comes in. If both fractions simplify to the same thing, you know they are equal fractions. And you're like, oh yeah, I learned that in what, 5th grade or something? Okay? That ratio of corresponding sides is called the scale factor. Get your candy. Okay? And I want you to put a big asterisk by that. For us, when we were working on the coordinate grid, and I didn't tell you anything else, how did you build scale factor? Nope, that's slope. It was always the new image over the old pre-image. Remember setting that up to figure out your scale factor? You want to know that for the quiz, because you're going to have to be able to do that. That's how we calculated the scale factor of your dilation. Okay? But a scale factor can go in any order as long as you know which direction you're going. And so that's why the asterisk is here. If I tell you which way to make your scale factor, make it the way I tell you. If I don't tell you anything that gives you any clues, go with the new image over the old pre-image. Okay? What if there isn't a new one and an old one? Well, then you get to pick. Okay? So there's going to be lots of options over the next few days where you get to pick the thing that works best for you. And you're going to love it or you're going to hate it or it's going to be a love-hate thing. You know, it's got to be one of those. If polygons are similar, their sides make proportions. Something else is also proportional. So take a guess. This could be just a wild guess.
Angles?
Angles are not proportional. The angles have to be congruent. Remember? And so what else could be that same scale factor as your sides? What can make the same fraction? Got a guess?
Shape.
Nope. Shape is that a number I can make into a fraction?
No.
No. So that, fun guess, but no.
The distances?
The distances are the lengths, which are the sides. So, no. Areas, they are proportional, but they're a different scale factor. They're a different fraction. They're a different number. But something else has the exact same proportion.
Perimeter?
It's perimeter.
Oh, yeah.
Because perimeters are made out of sides, right? So if they're a certain fraction, when you add them up, those perimeters should make the same fraction. Minds are blown all over the place, don't get brains on the floor, okay? So knowing that sides are proportional, you can use that to figure out what the scale factor is. But do you know which one's the new one or the old one? No. So it doesn't matter as long as you always pick the same thing first. So you might decide, I'm always going to pick the smaller one first. Or I might always pick the bigger one first. Whichever. But always pick the same guy first. Now here, I'm giving you a clue which one goes first. Which one does it say to do first here?
ABC.
Triangle ABC. So when I make a fraction, I'm going to pick something on triangle ABC first. So here's a fraction I'm going to make. And it's got to be, something from the first guy to the second guy. And they've got to be corresponding. So what's something on ABC?
Segment AB.
Segment AB. And that one, he chose that one. Do you have to pick that one?
No.
No, but he did. And so he said, okay, I'm going to choose 8. Now, what would be its corresponding buddy on the other guy? Yes?
Segment D.
He says segment D. How do you know for sure? There's a couple ways.
Because
How do you know they're corresponding?
they're in the same position.
How do you know they're in the same position? What if I had turned it?
They have the same angles.
Oh, this one has the single angle at the end and the double angle at the other end. Single, double. That's one clue. What's another clue you can look for? Ollie?
The triple one is like opposite from it.
Oh, this angle C with the triple
Yeah.
is across from 8, so the triple guy is across from 12. That's another way to tell they're corresponding. Yes, sir?
The order of like AB.
Here it says AB, so it has to go with DE. That's another way. What's another way? I love this one. Oh, and you think you've got it?
Well, just to look at the sides and see what makes sense. Like,
Well, AB is the smallest one on this triangle. Which one's the smallest over here? DE. The corresponding ones should be the same relative size, so the smallest one here better be the smallest one here. Okay, so look how many ways you have to figure out what's supposed to go together. You have lots and lots of ways to figure that out. That made a fraction. What's that fraction simplify to?
2/3.
It simplifies to 2/3. But the nice thing is, if I picked different sides and made a fraction, since they're proportional, it should be equal. So make me a new fraction.
A new fraction? 10 over 15.
And notice he picked the 10 to go on top because it's in triangle ABC, and the one you say first goes on top. And then 10 corresponded to 15. Does that also simplify to 2/3? Should work, okay? So what's my last set of corresponding pieces I can make a proportion out of?
14 and 21.
The 14 can go with the 21. And that should also, all of these, equal 2/3. So they are all proportional. And that should work with any similar shape that you make for the rest of your entire life. You're like, crap, that requires thinking now. But wait, yes.
Wait, well, wouldn't it be 3 over 2?
Well, it's at the small, look, smaller number on top, bigger number on bottom. Smaller number on top, bigger number on bottom. Now, because I'm comparing the littler guy to the bigger guy. But I'm glad, because now on the next one, same two triangles, but now it says compare the big guy to the small guy. So here I had small over big. This says to compare the big to the small. Should all my proportions still be the same? They should all equal each other. Now they're just all going to be flipped over. So if I'm doing DEF to ABC, I'll do 12 over 8. And I'll do 15 over 10. And I'll do 21 over 14. What do these all simplify down to? These all simplify down to 3/2. So they are all still equal. We're just comparing them in a different way. But they should all give you the same equal fraction no matter how you compare them.
But like if you're going from triangle like ABC to DEF, like 8 times 3.5 equals 12.
Yeah, so, right, but that's the thing, is this is not a dilation. So we're not using this to get from one to the other. What we're saying is that the top one, 8, is 2/3 of 12. 10 is 2/3 of 15. 14 is 2/3 of 21. This one, since the bigger number's on top, 12 is 1.5 times 8. Okay, so this is different than being a dilation. That's why scale factor here is a goofy thing. When we say scale factor about a dilation, it's talking about how to multiply certain things in a certain order to get the new guy. If I'm just using it as the fraction comparing two similar shapes, it's used in a slightly different way. The words are the same, but they mean different things depending on their context. And that can be tricky for brains sometimes, because some people's brains, I can see smoke coming out of their ears already. Okay? So for what we're doing here, just pay attention to whichever one I say first, always goes on top. So here, it says DEF to ABC, so which one's going on top, the big or the small?
Big.
The big guy. Oh, but here I'm doing perimeter. So what should be my scale factor of my perimeter if I do big over small?
3/2.
It should be the same as it was for the sides when I did big to small. So what should it be? 3/2. Let's check that. Find the perimeter of this big one and find the perimeter of the small one. Okay, which one do you have?
I have both.
Okay, what's the small one?
32.
And who has the big one? Yes.
48.
It is 48. If I put the big one, 48, over the small one, 32, and divide both of those by 16, guess what it simplifies down to? 3/2. So they are proportional to all the other stuff. It still works, which is nice. We're lazy, remember? Do you want to have to calculate that every time? If you can do it with the sides, why would you bother adding up to do it for the perimeter? Because the side scale factor is the same as the perimeter scale factor. And you're like, oh yeah, less work. We like that. Okay? And then you get to similarity statements. Remember doing congruent statements? Triangle XYZ is congruent to triangle PTQ or whatever? But for a similarity statement, I need a similarity symbol. Candy, to the person, you can tell me what the similarity symbol looks like. Was that a hand up? A little tentative? It doesn't hurt if you get it wrong.
Like the squiggle.
The little squiggle guy. The fancy typeface name for that is a tilde. But we can call it a squiggle. Okay, squiggles are fine. Okay? Because remember, in congruent, the equal said same size, the squiggle meant same shape. Here we're just the same shape, so we leave off the equal part and just do this. Okay, so for these two triangles, I'm going to say a triangle is similar to a triangle. But what do you have to do? You have to put them in the correct order. Just like with congruent, order matters. And remember, your corresponding angles are supposed to be congruent. So I would use the angles to figure out which angle goes with which angle. Do you have to say ABC? No. Could you say CAB just to be obnoxious?
Yeah.
Let's do it. If I did triangle CAB is my first one, what would I have to name the next one in order to make sure I had all my corresponding parts lined up? Yes.
FDE.
Is it FDE? Y'all check it, I haven't looked. C. C has 3, so C goes with F. A has 1, it goes, yep, I call that good. Get your stuff. Okay? All right? Questions on how that works? Are you scared yet?
Yeah.
You okay, Lise?
Yeah.
Okay. You okay, babe?
Yeah.
You doing good? Okay, awesome. Just making sure everybody's fine. I can't see some faces because they've got people in front of them, so I'm just double checking. I see yours. I can see you. You're good. All right. So here, oh look, I tell you that they are similar. So what's supposed to be true about all my angles? Oh, but none of them are marked. How do I tell which angles are congruent if none of them are marked? Yes?
The way it's written, because like, it says J and then P.
Yeah, since J corresponds to P, that means angle J better be congruent to angle P. And then you could go into the picture and mark them. Oh, gasp! They're not in the same position. Well, that means one of them got rotated a little bit. But that doesn't change that they're similar. All right, so what's going to go with angle K? Call it out. Angle M. And they're going to be congruent because similar things have equal angles. And angle L will be congruent to angle N. You are so scared. Look at that. Terrifying. Then we get to the hard part. Now, what's got to be true about the sides? They're proportional. So you have to build fractions now. And they're supposed to equal each other. So you get to pick when you build your fraction. Do you want to do big on top or little on top? I don't care. So do you want to do small on top or big on top? I heard big. If you liked small, can you build yours small in your notes? Yeah. But I'm going to do big on top and then small. You do them however you want. Now, if I tell you similar in this order, will it help you not be confused to use the one I tell you on top? Yes. So you can do it whichever way you want. Just to help not confuse people who are learning on the video, I'm going to pick the one that was said in the similarity statement first and put it on top of the one that said second, just to keep things going the same direction for everything. You can do it how you want, but some people like everything to all match up. Okay? So here, I've got JK first. So I'm going to make a fraction with its corresponding side. What corresponds to JK?
PM.
And see, here it is, right here, PM. So that's going to go in the fraction with it. And I've got the first one over the second one, small over big. Okay? When I go to make the next one, you get to pick which side you want to do next. So, what do you want to do next?
KL.
KL? What is KL going to correspond to?
MN.
Now, could I say it NN?
Yeah.
You could. NN is the same as MN. They are the same to one. But I'm going to stick with alphabetical because I'm that way. So JK went with PM. KL goes with MN. And so now all I have left is JL. Which one should it correspond to? PN, so that's going to go in a fraction with its corresponding side. And however big these are, each of these fractions I made should equal the same scale factor. If I flipped them over big over small, you should still get the same number, it's just going to be a different number because you flipped them all over. And so you go, okay, that's not too bad. What's different about this guy?
They're inside each other.
They're inside each other. I like to use color to help myself on these. So when it says triangle XYZ, I'm going to use this dark purplish whatever. And for the inside one, RYS, I'm going to trace it with red, just so I can see it better. Some people really need the visuals, and I'm one of those people, okay? And then the names in the triangles, since they're similar, should tell me my corresponding angles. So somebody who wants candy, name all 3 sets of corresponding angles. If you already got candy, put your hand down. You didn't already get candy yet? Cool, go for it. What do you got?
Angle X is congruent to angle R.
Angle X congruent to angle R. Yep, they're both first. Then what?
Angle Y is congruent to angle Y.
Angle Y is congruent to itself. It's the point for both of them.
And angle Z is congruent to angle S.
Angle Z is congruent to angle S. Boy, it's nice that we name it this way so we don't have to think so hard. Now you could go in and mark those if you wanted to, like if we were doing a proof. You could go in and mark them if you felt like it. Okay? Based on what you read up there. And then you could build your proportion. They should all have equal ratios. So somebody else who wants candy, build me my 3, somebody who hasn't gotten it already. You haven't gotten candy yet? Well, let's get you out of the way then. Okay, so build me a ratio. Let's go in the order it says up here. So start with the big guy and then do the little guy.
So XY over RY.
XY goes with RY. That made a fraction. Whatever its value is, it should equal the next one. What do you got?
YZ over YS.
YZ over YS. And then
XZ over RS.
XZ over RS. Now, one thing I need to point out. What did I not draw on here? The segment bars. Because these are numbers in fractions, aren't they? I'm building fractions. I don't know what the number is, but I know it's the length of XY over the length of RY. Since these are numbers, I do not put bars over them. So be aware of that, because it matters. Some of you have gotten kind of lazy about that, but it matters. We are talking about numbers, leave the bar off. Okay, that will count for points when we get to the test.
So whichever one you're doing first, like XY, that would go on top.
I'm picking that because it was the first one we said in the similarity. Okay, if you confuse easily, whichever one you say first here, just always put it on top. Whatever said first goes on top. Okay? Would you like to do it with a quadrilateral, or do you think it works the same?
It works the same.
It works exactly the same. So we're going to move on to using what we just learned to find missing sides. And again, order matters. So on this one, I tell you, these guys are similar. Those aren't triangles. What are they?
Polygon.
They are not rectangles.
Polygon.
They are technically polygons, but they're a special polygon.
They're trapezoids.
They are not trapezoids. They are parallelograms, which is a kind of quadrilateral, okay? That's our next unit. Okay? But for now, we're just going to use being similar. Okay? So I want to find x. The only thing they tell me is that my scale factor is 2 to 3. So I know, if I say it first, where does it go in the fraction? On top. On top. So my scale factor looks like 2/3. And I know that that should equal the fraction I make out of the sides if I do them in the right order. How do I know which order to put the 42 and the x into this proportion? What do you think?
40, like the parallelogram is smaller.
Yeah, look, it said smaller to bigger. 2 is smaller than 3. And so that tells you, here's where you get to trust the picture. This looks like the smaller one. So it gets to go on top. So the 42 is smaller, gets to go on top of the x because the picture looks like it's supposed to be bigger. And then you have to remember back to the dark ages of like 6th or 7th grade. How do you solve a proportion when you're missing something? Now you could do the whole thing, oh look, it's divided by x times by x on both sides, but there's a shortcut. Yes?
You multiply 3 times 42 and 2 times x.
Yes, you do the multiplication in a diagonal. What was some of the names you had for this thing?
Butterfly.
It's either the butterfly method or called cross-multiplying. It's always when you're jumping across the equal sign in a proportion like this. So you're going to get 2x equals, what is that, 126?
Yeah.
Yes, I remembered it. Okay? And so, what does x come out to be?
63.
63. So that means that 42 over 63 should simplify to 2/3. If you did it right.
One.
Could you check it if you felt like it?
Yeah.
Yeah, you could get a calculator and check to make sure it works. Okay? So now in number 5, which number is going to go on top? The bigger number or the smaller number?
Bigger.
The bigger, because the bigger number is first. 6 is going over 5, which means here I should put the thing that's bigger on top. Which one's bigger, x or 28?
X.
So the x is bigger, so it should go on top. And yes, I'm talking to you like you were 5 years old because it makes me feel better. And so you would cross multiply everything, and 5x would equal, what is 6 times 20?
168?
I don't know, do you have a calculator?
No, I use my brain.
Oh, how dare you. Brains?
Yeah, dude.
It is 168? Well done, Josie. I'm proud of you. And then you divide it by the 5 and it's going to be a decimal, but that's okay. What do we get? Can you type that in and check what that is?
33.6.
She's saying 33.6. Is that what you get? Okay.
You just leave it as a fact.
You could leave it as 168 fifths, but you're going to want to make sure it is simplified. Okay? But for us, if it's not obvious, go ahead and throw it into a decimal. Okay? Because it's probably going to be something basic and not something like pi. And so we're going to be okay. It's going to be rational.
I can go for some pie right now.
I could go for some pi right now as well, but alas. Okay? Would you like to do more of them?
No.
Well, okay, what would be different about 6? Did I tell you the scale factor?
No.
Oh. If I didn't give you the scale factor, how do you know how to build it? What's that? If I did new with old, do I know which one's the new one and which one's the old one? You don't know. So this is where you have options. Now, most people like to stick with the order this is in. So pick something on triangle ABC and put it on top of something that's in triangle DEF. That's how a lot of people would pick it. But could you pick to just do small over big?
Yeah.
You could. It doesn't matter. If you like things to stay organized and not be scary, do it in the order of your similarity. But if you want to mix it up and be a rebel, you could do it in the opposite order, just don't confuse yourself. Okay? And so for this one, if I do ABC on top, then you have to pick which side goes with which side. So if I do this one, and let's say I start with X, I'm going to put the thing on my ABC triangle on top. So X is going to go on top. What's the piece in DEF that goes with it? How did you know it was the 25? Because it's corresponding in the name. AB goes with DE. Whatever that fraction is, it should equal the fraction I build out of another set of sides. So, should I bother picking AC? No, I don't know anything about it. So guess what I'm stuck with? The 28. Because I'm picking something from this guy first. So 28 goes on top. What's his buddy?
20.
The 20. And double check that that really goes with it. This is BC, should go with EF. Okay, we're legit. Okay, big over small, big over small. And then you can cross multiply. I don't know what 25, is that what, 700? And then it comes out to be what, 35? 70 divided by 2 is 35? Okay. And so how I give stuff to you is your biggest clue of how to build your fractions. And there are options. There are actually 8 correct ways to build your proportions. And I don't care which way you do it, but most people want to stick with what I give you because it's less confusing. Okay, turn it over. Lots of examples here.
Numbers like 100 be converted.
Say what?
100 be converted 15.
300, no, because 700 divided by 20, the 10s divide out, and it is 70 divided by 2. Okay. Look at number 9 for me. Shh. Which one are you going to put on top? Probably JKL, which is the bigger guy. Okay? And I'm trying to find X in the bigger guy, so I'm going to put him on top. Okay? Who's the correspondent to X on the other guy?
14.
Oh, is it Y? I heard someone say Y. They're both on top. But don't be bamboozled. Here, if I'm doing KL for X, KL should go with ML. And ML is down here at 14. So be careful. Don't just go off half-cocked assuming that it goes, the way it looks in the picture. Use what I give you to tell you what to put. Okay? Now, to do this, I should make an equal ratio. Okay? Well, should I use the 45 to go on top? Because that's a nice big one. Why wouldn't I use the 45? Because it corresponds to the Y, and I don't know that. Do I want two letters in the same problem? Not if I can avoid it. So is there another fraction I can make that just uses numbers?
40 over 16.
I could use the 40 with the 16. So I'm going to put the left one on top and that one on bottom. Okay? And you can solve that using your normal methods and all the good stuff. And that's going to come out to give you X equaling 35. Yes, I have a cheat sheet. How am I going to get Y? What do you think?
So you replace X with 35 and
No, I don't have to actually. Yes?
40 over 16 equals 45 over Y.
Yeah, I could keep going and saying, oh, I know the 45 goes with the Y. Could I just focus on this proportion now? I could use the same known sides and do it with this guy. Now, Noah, you were not wrong. I could put the 35 in and use that one with the Y, but, people like to do it this way as well. There are options.
Also, if you get
Once you solve one of them, could I have used the 35 and 14 to solve for the Y and 45? Well, yes, I could. So you get options. Once you find one, you can use it to find another, or you could keep using the stuff you already used. You get options. And in this case, Y comes out to be 18 and all is well with the world. Okay? So you could use it here with this problem and use it here with this problem. It's up to you. Just be careful that you put corresponding stuff with corresponding stuff, because I will try to bamboozle you. Okay, I'm very fond of that. Slide down to the bottom here. Oh, garbage. Nope, we don't have time. We gotta get going. Turn the page. Okay. Implied statements to memorize. You have 3 of them. Does this seem kind of familiar?
Yeah.
Yes.
This is like your congruent implied statements. But now they're about similarity. Shh. So AA squiggle means angle-angle similarity. Guess what angle-angle similarity implies?
Similar triangle.
Similar triangles. This says side-side-side similarity. Guess what side-side-side similarity implies?
similar triangles.
Similar triangles. Guess what side-angle-side similarity implies?
Similar triangles.
It implies similar triangles. I hope you can memorize those for the implied statement quiz.
It's gonna be a little hard.
What's hard about these is not, could you put AAA?
Yeah.
Technically, yes, because if two sides, hi guys, please stop talking. If two sides are congruent, but they have to add up to 180, doesn't the third side also end up being congruent?
Yes.
Yes, but you only have to find two of them because it's going to force the third one to work anyway, and so you don't have to bother doing the work. You just have to find two of them. Okay, so if two corresponding angles are congruent, the triangles are similar. So down here, there's one set of corresponding angles. Here's another set of corresponding angles. That gives me an angle and an angle congruent, which gives me angle-angle similarity. That's how that works. If you've got those, you can say they're similar. What about this one? Oh, I only have one set of angles congruent here. What do I have? Oh, the vertical angles can also be congruent to each other. So this one also has a set of angles. This is still angle-angle similarity. Okay, so don't be bamboozled just because I don't spoon feed you everything. Double check to see if some of the things you can use your brain to find out work. Side-side-side similarity is kind of like side-side-side congruence was. You need all three sets of sides. But are they going to be congruent?
No.
What are they going to be? They got to be proportional. So you have to build three equal fractions in order for this to work. So you say, okay, what's 3 going to go with?
6.
6, because they're both the smallest ones. 3 goes with 6. What's my biggest ones on both of these?
5 and 10.
5 and 10. What are my medium ones?
4 and 8.
4 and 8. Do those all equal each other?
Yes.
What do they all simplify down to?
1/2.
If I have 3 proportional sides, then that is side, side, side. Yes, go ahead. Okay. 3 equal fractions. Could you have thrown it in a calculator and gotten 0.5 for each of them? And still call it good?
Yes.
Yeah, that's fine. Side angle side similarity is like shuffling these together. So how many proportional sides do I need?
2.
I need 2. How many congruent sets of angles do I need?
1.
Where does that set of angles have to be?
In the middle.
In between
This side.
where the two proportional sides are. It has to be the included angle. So here I have a set of congruent angles. So check on the angle. Do I have sides that are on either side of that angle?
Yes.
Yes.
Yes, but are they proportional? Do they make equal fractions?
I don't know.
Let's find out. Shall we do big over small? So I'll do 8 over the 6. Does that equal 20 over 15?
Yes.
Yeah, they should both equal what, 4/3? So they're arranged side angle side. I've got the 2 equal fractions, and I've got the congruent angle, so then yes, I can say that side angle side similarity works.
Okay.
Okay? Be careful of the nested ones. What's going to be the congruent angle here?
A.
It's going to be the one they share, because this big triangle contains angle A, and the little one contains angle A. So angle A has to be congruent to itself, right?
Yeah.
So that's the angle you pick. And then you check the sides that include it to make sure they're proportional. And so you're going to get to practice this, but sadly, we only have a couple minutes left, and so I'm going to go ahead and let you wrap up. Okay. Where is my...
Hold on.